Got a lot of questions about number 9 off of the practice today. And the idea behind here, our goal in converting from polar equations to rectangular equations, is we want to take a statement that has r theta. Those are our polar coordinates. And we want to turn this into rectangular coordinates. That's our xy. So as long as we can get rid of, eliminate, replace, substitute for the r and the theta in our expression using terms of xy, we've substituted in, we've changed it to rectangular coordinates. Now what we've seen so far is available for substitution based upon our definitions. We've got x can be replaced or can be used for r cos theta. Y is equivalent to r sine theta. We've got the Pythagorean theorem, x squared plus y squared equals r squared. And we've got the slope, tangent of an angle, is y over x. Now number 9, there's cosecant, there's an r, but getting through things. If we square both sides, well, we would have r squared equals, but then we've got cos x squared plus y squared. On the right side, however, we're going to have cosecant squared. And we can use a trig identity, one of our Pythagorean identities, where cosecant squared is equal to 1 minus, cotangent squared plus 1, but that really doesn't help us. Instead, we're going to take advantage of this sum here. We're going to need to connect back to our trig sum identities that were listed on the assignment. So here's the strategy that we're going to take. I'm going to first rewrite cosecant using our trig identities. That's division by sine. So this is 4 divided by sine theta plus pi over 6. I'm going to cross multiply. I've got r sine theta plus pi over 6 equals 4. And you go, ooh, r sine theta, that's y. Almost. This is just theta. We've got pi plus pi over 6. We need to expand that so it's just r sine theta. We're going to take advantage of our sine sum formula at this point and expand that. I'm going to go through and distribute my r term as well at the same time. We've got r sine theta cosine pi over 6 plus r cos theta sine pi over 6, ran out of room, equals 4. That r sine theta popping up, that's y. Cosine pi over 6, we know that off the unit circle is root 3 over 2, plus r cos theta, that's x. Sine pi over 6, we know from the unit circle, that's 1/2, equals 4. There we go. We're now in terms of rectangular coordinates. Let's take another one. I didn't show all of the steps for number 12. I just said here it is. But let's take a look at number 12 as well. On the screen, there we go. We have r squared equals 4 secant 2 theta. And again, what we need to do is think about, okay, secant 2 theta. Well, secant, that's division by cosine. That's 1 over cosine. I can rewrite this as r squared. R squared is already one of our statements. That is 4 divided by cosine of 2 theta. Now I'm going to throw back to our double angle identities. This gives us r squared equals 4 divided by 2 cosine squared theta minus 1. If I cross multiply and distribute, that's going to give us r squared, 2r squared cosine squared minus r squared equals 4. So I cross multiplied, end up with that. There's our nice piece. We've got r squared cosine squared. Well, this is 2. That's r cos theta squared minus r squared equals 4. There's our r cos theta. That goes back to one of our substitutions. We've got 2x squared minus r squared, so minus x squared minus y squared. I distributed the negative, equals 4. And combining like terms, we have x squared minus y squared equals 4. That's number 12. Got to be creative in this. Look for some identities. Look for some things. If we're using an identity, I don't expect you to recall all of those immediately. I'll provide them when necessary. but sometimes we need to be creative in how we can find each of those available substitutions that we're allowed to use. All right, catch you later.